So this is the third question of CodeForces round 923 division 3. Choose the different ones. Okay. Now in this question, you're given an array A of n integers and you're given an array B of m integers. And you're also given a number k, which is even number. Okay. So keep that in mind. It's an even number, right? Now what you need to do is we basically need to pick up exactly k by 2 elements from both the arrays such that we get all the integers from 1 to k. Okay. So let's say this is the array A and this is the array B. Okay. And k value is 6. Okay. So what we do here is we basically will try to pick up 6 by 2, which is 3 elements from here and 3 elements from here. Okay. And after picking up three elements from both places, we need to get all the numbers from 1 to 6. Okay. Now let's see if it's possible in this case. We can pick up 1 from here and we can pick up, let's say, 5 from here and 4 from here. Okay. And here we can pick up 2 and 3 and 6. So basically 1, 4, 5, 2, 3, 6, and we'll be able to pick up all the elements we require, right? So that's how it will be solved in this test case. Okay. And let's look at the constraints. Constraints are t value can be up to 10 power 4, n and m value is up to 10 power 5, and k value can be at minimum 2 and at maximum it will be 2 into minimum of n comma m, right? And k is an even number. Okay. Also, the array values are up till 10 power 6. So both of uh, the array elements, I mean, are up till 10 power 6. Okay. They have also mentioned that the sum of n into m overall test cases does not exceed 4 into 10 power 5. So yeah, this is an important constraint to keep in mind. And we just simply need to say yes or no. Okay. So we don't need to say which elements we pick up from A and B. We just need to say one thing, that with whether it's possible or not possible. Okay. So yeah, that is about the question. Let's see how we can solve this question. So to solve this question, we are going to need three different kinds of information, and I'll explain what that is. I'll call the first piece of information as count A. Okay. Count A is basically the number of elements from 1 to k. Okay. Number of elements from 1 to k that are present in A but not in B. Okay. Also, it's not number of elements, it's number of unique elements. Okay. I'll also mention here unique elements. Okay. And another value called count B, that is number of values present in B but not in A. Okay. And this is also number of unique elements. Okay. Number of unique elements present in A but not in B, and number of unique elements present in B and not in A. And these are all the elements in the range 1 to k only. Okay. Once we have this set of information, now we can say with surety that if there is something in A and that is not in B, and it's also in the range 1 to k, then it means that we definitely need to uh, include this element from the A only, right? Because it's not present in B at all, right? Also, this value also needs to this value also tells us that it's present in B and not in A, and it's from 1 to k, right? So we definitely need to include it from B only, right? There is no other way for us to include that element, right? Now, obviously, there can be some numbers that are present in both A and B. So this value might not be k by 2. I mean, might not always be more than k by 2, right? It can be less than k by 2. Okay. Now, The third piece of information that I need is I want to know if there are any elements, if any elements not present in both A and B. Okay. So basically, we just need to know if there is any elements. Okay, I'll just write from 1 to okay. Just make sure every information is from 1 to k only, because any number that is not from 1 to k is not important for us at all, right? So if there are any elements from 1 to k that are neither present in A nor in B, then in that case we can say that our answer is simply no. Okay. In that case, we don't need to do anything else. We just simply say the answer is no. Okay. Now for count A and count B. Okay. Now, since we have to include all the elements from count A and all the elements from count B as well, what can we say? We can say that the count A value has to be less than equal to k by 2, right? Because if it's more than k by 2, which if it's more than k by 2, then it means that our test case is demanding us to include more elements from A than we can include, right? So count A has to be less than k by 2, and count B also has to be less than k by 2, right? So if either of these conditions fail, then our answer is no. So we can put it in a simple way. We can just say if count A is more than k by 2 or count B is more than k by 2, then that means that it's a no. Okay, right? So if you have checked this condition, if you have checked this condition, and if you have checked this condition, then in all the other cases, the answer will be yes. Because in all the other cases, we have all the elements from A and B, and this condition ensures that the test case is not demanding us to include more than k by 2 elements from a particular array, right? So these both conditions checked, we will get our answer, right? Now, uh, some of you might be wondering, how can we find out the value of count A and count B? Okay, basically we need to find how many numbers are present in A but not in B, and that to unique elements, right? So now this is where using sets will be helpful to us. Okay, what we can do is basically, let's take an array example. Okay, let's take an array. So let's say we have an array A which has elements 2, 3, 8, 5, 6, 5. Okay, and B has 1, 3, 4, 10, and 5. Okay, and let's say that the k value is 6. Okay, k value is 6, so we just need to include three elements from both the arrays, right? Now, how do we find out the value of count A and count? Okay. Now, first thing is we'll basically construct a set. I'll call it a set A. Okay. Set A will hold all the values in A that are in the range 1 to k. Okay. Because numbers that are not in the range 1 to k are not relevant to us. Okay. So we'll get 2, we'll get 3, we'll get 5, and we'll get 6. Okay. And we'll construct another set called set B, which has numbers 1, 3, 4, and 5. Okay. Now that we have set A and set B, we know that in set the complexity for finding is log n, right? If it's a tree set, it's log n. If it's a hash set, then it's O of 1. Okay. And when I say log n, I mean log of the size of the set. Okay. Right. Now, how do we find count A and count? Basically, once we have put elements into set A and set B, what we do is we iterate over the array again I mean, not over the array. We iterate through all the numbers from 1 to k. Okay. So we iterate from all the numbers from 1 to k and check whether they exist in set A and set B. Okay. So just putting a few if conditions will get our answer. We need to just check if it is in set A and not in set B, then we can increase the value of count A. Okay. If it's in set B and not in set A, then we can increase the value of count B. Okay. That's the simple approach, right? And once we have count A and count B values, we can easily compute our answer, right? Basically, both count A and count B values must be less than or equal to k by 2. If either of those conditions fail, our answer is a no. Okay. And yeah. And while checking, while putting elements in set A and set B, also check one more condition here. If there is some element from 1 to k that is neither in set A and neither in set B, then we can simply say no from there itself, right? So yeah, make sure to put that condition as well. Yeah, this is basically how we solve the question. Coming to time complexity of this approach. Okay, the time complexity of this approach will be O of n only. It will be O of n log n if you're using a 3 set. So this is for 3 set. Okay, and it will be O of n if you're using a hash set. Okay, right? And but either of these solutions will get accepted because log n complexity is very small, right? And space complexity of our approach. So space complexity will be what? Basically, array A and B is given to us, right? Right. So A and B is given to us, so we'll have O of m plus n. Okay. Now here it's actually not n log n. Okay. Let me just make it with respect to m as well. Okay. So it will be O of n. O of n plus m into log of max of m comma n. Okay, that's how it is. This is also smaller only. Don't get afraid by the big expression. Basically, it will be n to n plus n, which can be only up to 2 into 10 power 5, and max of m and n is also up to 2 into 10 power 5. So this overall complexity will also be smaller only. Okay, or O of n plus m, n plus m if you're using a hash set, right? So yeah, that's how we solve the question.